Welcome to Lab 4, Pressure Measurement, by George, Alessandra, and Russell. To get started, I'll just introduce what this lab is about. In this experiment, we will explore two different configurations for measuring pressure based on the strain experienced by cylindrical objects. The purpose of this lab is to gain a practical understanding of how strain gauges can be used to determine pressure and to identify potential sources of error or discrepancies between theoretical and experimental results. Now let's go head on into the lab to look at our procedure. Here we are sanding the Coke bottle so that the glue will stick to it. And then we applied some glue to the sanded area of the Coke can. There I am, just applying the glue. And then we attach the strain gauge to the part with the glue on it. Kind of tap that in to make sure it sticks. And here's the point where I realized, hey, maybe I should call a friend for this. So I phoned in a friend, and here is, I believe that's George, helping me stick on the strain gauge to the Coke can. So here I am taking a little piece of tape, sticking it onto the Coke can so that we can go ahead and get our pressure measurements from when we opened the can. Next, here's our lab view setup, just so you can take a look of how we set up our lab view for collection. And there's our collection window. Here is George changing the pressure on the polycarbonate cylinder so that we can calibrate our strain gauge. So there he is, just setting the pressure, and then once he sets the pressure, we go over to our lab view and we wait for it to reach equilibrium, and then we measure the value that we see. Next, we set up the Wheatstone bridge in a quarter bridge configuration, as shown there. That's our beautiful quarter bridge configuration. There's our lab view getting ready, and then we get it recording, and then we pop our can. And then, as you can see in the lab view, the voltage jumped up in amplitude, our collected signal. So yeah, and then we recorded that, and then next comes data analysis.
Hi, I'm George, and I'll be presenting the data and results for part 1 of this lab. So we can start off with the raw data that we collected during the experiment. We can see that for each of our 3 trials, we collected the voltage output from the strain gauge for the gauge pressures between 0 and 30 in increments of 5 psi. We're also using a couple constants that were given to us here in the equations right here. So we can see that the first equation that we're going to be using is the voltage ratio equation, which converts our raw data into a useful change that we can use to calculate the measured hoop strain. We can then combine this measured hoop strain equation with the equation for theoretical hoop strain in order to obtain an equation for the measured pressure. We can then perform the calculations using the constants and our raw data to come up with the following numbers. We can see that for all 3 trials, the measured hoop strain and pressure match up pretty closely with each other, just from a first glance, which is good. We can also visualize this a bit better with the following graph, where we're plotting the measured pressures as red X's against the true gauge pressures, which are blue. We can see that the measured pressures have a small amount of noise, likely due to the fact that we were eyeballing the pressure on the gauge. But we can also see that, more importantly, the measured pressures, as the measured pressures diverge from the actual gauge pressure as the pressure increases, having a slightly different slope. And this is likely to the fact that the gauge factor that we are currently using might not be perfectly spec'd with our specific strain gauge.
Hi, I'm Russ Lambert, and this is the data and results for part 2 of the lab where we measure the unopened pressure of a Coke can. So this is the raw data. We took 30 seconds of data at 1 kHz, and this plot shows our voltage over time in millivolts. On the right, we have values that will be important for calculations. All of these were given in the lab except for unstrained voltage, strained voltage, and atmospheric pressure, where unstrained and strained voltage are the points on either end, strained being all the way at the end of the data recording and unstrained being at the beginning. And atmospheric pressure is something I Googled. So these are equations that were important for calculations. Voltage ratio is a combination of a couple equations given in the lab, where pressure change and strain change were both given explicitly in the lab guide. True pressure was one I derived myself based off of the fact that after the Coke can is opened, it reaches atmospheric pressure. And delta P steady is the delta P value at the very end of the data recording. So these plots are represent the data after it's gone through some calculations. So you can see down here, delta P steady came out to around 18 psi, which can be seen in this plot right here at the end. And after it's been put through the last equation for true pressure, we get this plot, which makes some logical sense as the pressure starts high, and after the can has been opened, we see a drop, and then equalizing out to near atmospheric pressure. And this just shows the change in the strain while the can is being opened. And we can see here that the final calculated value for the unopened soda can pressure, just by using this equation at the final time of 30 seconds, gives us 32.9925 psi. Thank you.
In conclusion, there is a linear relationship between pressure and voltage. As pressure increases, the error between gauge pressure and measured pressure also increases. As expected, when the soda can was opened, the soda can pressure dropped dramatically. Thank you so much for watching. This was Lab 4 Pressure.